So thank you very much, Thorsten. Welcome again for everybody. And these are my disclosures, and I will talk about the B-cell depletion therapy, as you know, which is a very effective therapy in many modalities nowadays. And you all know, of course, that it came from the lymphoma therapy from B-cell malignancies and is nowadays widely used as a blockbuster in rheumatoid arthritis, in morbus Wegener glomerulomatosis vasculitis, in multiple sclerosis, glomerulonephritis, in organ transplantation, etc., etc. I could continue for long here, and there are probably many indications coming up in addition to this. Now, rheumatoid, as you all know, is an autoimmune disease, increased mortality, affects 1% of the population. You're all familiar with. I don't have to go through the details. And of course, this is the feature we want to avoid and do avoid nowadays mostly. And of course, we have these lymphoid follicles in the germinal centers, which are formed in the synovial tissue once it's inflamed in the rheumatoid arthritis. Now, there is this kind of B-cell depletion therapy which I referred to, but you know, B-cell depletion or B-cell therapy isn't a focus nowadays in autoimmunity and immunosuppression, and many more antibodies are coming up. Rituximab has just come up, and Rituximab is also in the market. These other two antibodies are still coming. So, and in addition, we have a number of reagents directed against these B-cell activating factors like BAFF receptor, TACI, or BCMA. And as you all know, also belimumab against BAFF is in the market for lupus. Now, I will focus in my talk just on CD20 depletion, the original B-cell depletion therapy, and tell you about some aspects which you probably in the understanding are not that much aware of, because of course everybody thinks that the main mechanism in CD20 depletion therapy is the B-cell depletion and thereby eliminating the autoantibodies or maybe even some other antibodies, and all the rest we really do not understand very well. I will show you data that in fact you are depleting with your B-cell depletion also a subset of active T cells. And I also will show you in my talk that the depletion of B cells has very critical role by depleting the antigen presentation. And I also will show you consequences of this. Now, when we looked, and this is work done by Roland Jacobs in our laboratory, looked in peripheral blood in humans, and we knew that CD20 positive T cells have been described in mice. We find that 0.1 to 6.8% of peripheral blood cells co-express the CD20. As you can see, it's a low CD20, but it's clearly CD20. As you see when we stain this together, this is with CD90 now. Now, the distribution of the CD23 positive dim lymphocytes you see in various organs. You can find them in the liver. You find there's T cells also in the lymph node, and you also find it in the thymus. So, in fact, low CD20 positive T cells. And just to prove it for you that these are really CD20 stained cells, we did blocking studies here. And this is without blocking. And when we block these antibodies, these antigen with other CD20 antibodies, you see that we can completely eliminate their appearance. Now, not only that we have the CD20 on the surface, there's also in these cells specific CD20 specific RNA, messenger RNA, and you see the gene expression here on typical T cells, CD3, CD20 positive T cells on the classical CD20 B cells. And when you look for the RNA in CD20 positive cells as opposed to the CD19, you also have CD20 RNA in these T cells. And when you enrich these cells, T cells, and check for the more closely for these cells, then you have even a higher number of these B cells by depleting with all these various monoclonal antibodies. Now, people then still doubted our findings that may be real, and so we also did chip cytometric analysis. And then you that is a technology where you have the cells on a chip and you stain them, destain them, can restain them, and can do that for 100 times. It's a very elegant technology. This is just the picture with transmitted light, and then we stain for CD20, and then you see up here the B cells, down here, as you will see, the T cells, and with CD3. And finally, that you see that the B cells is not stained by CD3. And finally, if you now co-stain with CD19, and you have clearly here the CD20 positive T cells, which are not positive for CD19. So we also looked for the co-expression with other markers like the TCR1 and TCR2. There's almost equal distribution, and also there is not much difference. There are some more CD8 cells in the CD20 positive T cells. Now, this shows you just a long list of rheumatoid arthritis patients, and here's the number of the CD3 positive CD20 T cells, and you see that they range usually around 1 to 2 or some more than 2% in peripheral blood. So in the synovial, in fact, the percentage is higher. There's even up to 6% of the T cells in synovial fluid which express the CD20. What I also should tell you, actually, we did functional studies, which I don't show here, and these CD20 positive T cells are very active cytokine producers. And much more than the CD20 negative T cells, so the typical T cells. So when we did depletion of T cells, then that's a picture you're well aware of. But here we look for the T cells, then you see that they are completely depleted, and that you not only deplete the B cells, but you also deplete the T cells carrying the CD20 antigen. The summary of this is that there are CD3, CD20 positive T cells, and in peripheral blood it's 1 to 2%. In liver and lymph nodes, they rate up to 7 to 8%. In synovial fluid, 4 to 7%. 50% co-express CD8 positive markers, and they have a co-expression, which I also didn't show you, with a number of activation markers, and I mentioned already they are also present in mice. So certainly also we think that the elimination of these very active T cells may also play a role in their activity in immune suppression. Now I show you another. This work was actually done by Esther Wilk and Roland Jacobs in our lab. Now I show you another study we did together with Thorsten Witte, our chairman, and Teresa Franz and Ulrich Kalinke at the Twin Core, which is in Helmholtz Institute on our campus. So what we usually do, as you probably all do as well, in the fall, we immunize our patients against influenza, which I think should do regularly. So we did this in this case as well, and compared two groups. We took patients under Rituximab, which those who had Rituximab, and we took also vaccines on those who did not receive Rituximab. And then we compared, basically, we looked for we had them HLA type, which is an LA2 pentamer, and we could then look for CD8 positive, HLA positive cells in these patients. And what Teresa found when comparing these two groups is that, in fact, those people not receiving Rituximab had a nice increase of that CD8 positive vaccinia influenza-specific T cells, whereas those receiving Rituximab did not show any response at all. Not only, I'm not talking here about the B cells and the antibody production, what is usually looked at, but in fact, they did not show any response of CD8 positive T cells, and just see it in the bar graph here. There's clearly a very significant difference, basically no response in these patients. and basically shows you if you eliminate the B cells, obviously, and influenza vaccination is just an example for antigen presentation, then obviously you will not see the interferon response and also not see any CD8 positive T cells. So the B cell, in summary, B cell depletion may act by various immunosuppressive mechanisms, one of which is certainly what we all know and which we all believe in, the decrease of B cells and thereby decrease of autoantibody production. Second is certainly the depletion of highly active T cells, highly cytokine-producing T cells. And third, the depletion of that important B cells, which are obviously a key in antigen presentation, is leading to suppression also of the antigen-dependent T cell response. That's the work, and thank you very much for your interest, and I'm happy to take questions.